Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of solids using the Solid Edge software. Coming to the problem statement. A square prism, 35 sides of base and 60 axis length, rests on HP on one of its edges of the base, which is inclined to VP at 30 degrees. Draw the projections of the prism when the axis is inclined to HP at 45 degrees. Looking at the problem statement, we can arrive at a set of conclusions. The first one being the type of solid. So, the type of solid being mentioned here is a square prism. Next is the resting condition. So, the resting condition is it is resting on one of its edges of the base. And next, coming to the inclinations. So, the inclination is with respect to the HP, the axis is inclined at an angle of 45 degrees. And coming to the vertical plane, it is the edge on which it is resting initially, which is inclined to VP at an angle of 30 degrees. So, what are the conclusions? Since it is the edge which is resting on VP at an angle of 30 degrees, so it is the dimension which is not going to change, and that particular parameter is being considered for inclination with respect to the vertical plane, and hence it becomes a non-beta angle problem. So with this much of data, now let us see how to draft the solution for this particular problem statement. So we shall begin by drawing the line of thickness 0.18 and annotating this line as the xy line and also the reference planes as VP and HP. So now we will draw the top view of the square prism which is resting on one of its edges of the base. So now we can just choose a line of thickness 0.50 and then draw the top view of the square prism. So here the top view is looking like a square of dimension 35 cross 35. So now this is the top view of the square prism. So which means that this is the top face of the square prism which is visible to the observer in the top view. So now we will annotate this square prism. So the top face being A. So the corners of the top face being A, B, C, and D. Also, we shall annotate the bottom face of the square prism inside the square bracket. So this is A1 and this is B1 and this is C1 and this is corner D1. So this represents the top view of the square prism. So now let us try to mark the center of the square prism. So for that, let us draw the diagonals. So since the diagonals are not visible to the observer, they are just the imaginary entities. We shall draw them using the projection lines of thickness 0.13 So the point of intersection of these two diagonals shall mark the point of origin of the axis. So now let us draw the axis line from the intersection of these two diagonal lines. So let us take a projection to intersect the xy line. Okay, and then draw the projection lines from the other corners also. So we shall annotate the center of the square prism as O and O1, where O is the center of the bottom face of the O1 is the center of the bottom face of the square prism and O is the center of the top face of the square prism. So we'll annotate this as O and O1. So now we shall draw the front view of the square prism. So we shall select a chain line to draw the axis. So the axis is going to measure 60 in its front view. And next we are going to draw the front view of the prism. So we shall select a line of thickness 0.50 and ensure it is a continuous line. So we shall draw the corresponding front view. So with this, we have completed the front view of the square prism. Now let us annotate the front view of the square prism. So it is resting on one of its corner, that is uh, A1 and B1. So if the observer is going to look from this direction, for him, the corner B1 is visible. So it is B1 dash, and inside the bracket, it is A1 dash. And similarly here, this particular point marks the O1, that is the center of the bottom face of the square prism. So this is O1 dash, and similarly here we can annotate this as C1 dash, and inside the bracket it is D1 dash. So now we will annotate the top face of the square prism. So which is B dash, and inside the bracket this is A dash. And similarly this point is going to mark the center of the top face of the prism, which is O dash. And similarly this is C dash, and inside the bracket this is corner D dash. So with this we have completed the front view of the square prism, which is resting on one of its edges A1 B1 on the HP. So now with the next condition, he tells that the axis of the square prism is inclined to the HP at an angle of 45 degrees. So we will take the inclination of the base angle here, which is calculated as 90 degrees minus the inclination of the axis, that is 45. So the inclination of the base is 45 degrees. So we will consider this front view, select the front view of the square prism along with the axis line and the annotations, and then let us go for selecting the move option. Ensure the copy is on, and keeping B1 dash and A1 dash as the point of reference, let us move this front view of the square prism to the right hand side of the XY line. And now we shall rotate this. So keeping B1 dash A1 dash as the first point of center, and next C1 dash D1 dash as the next point of center, and ensuring the copy is off, let us rotate let us incline the base of the square prism at an angle of 90 minus the inclination of the axis, that is 45, and this is also 45 with respect to the HP. So this completes the front view. So ensure that all the annotations corresponding to the front view shall be above the XY line. So this has completed the front view of the square prism with its axis inclined to the HP at an angle of 45 degrees. So we can check that by using the extend to next option. Let us extend this axis line to intersect the XY line and then measure the inclination, which is 45 degrees. So now we shall draw the top view of the square prism. So for that, let us draw the projection lines from the front view. So if you have made this a continuous line, you will not be able to get these points. So ensure that all these lines are the broken lines. And similarly from this corner of the bottom face of the square prism, let us draw the projection lines vertically downwards. Now let us draw the projection lines horizontal plane, that is from left hand to the right hand side. So you can trim the lines which is not required for us for the construction. Now let us draw the top view of the square prism by selecting a line of thickness 0.50 mm. So now this is the first point. So now let us mark the top face of the square prism, so which is visible to the observer. And similarly, if the observer is going to look from this direction, for him the farthest corner point is the corner A1. So from A1 it will be a dotted line. So this will be a dotted line, and similarly we will mark the other edges. So this, so it is again the point of intersection has to be selected carefully. So this marks the bottom face of the square prism. So now let us connect the corresponding edges. We can use the trim option to trim this lines. So this is the axis line, so we will just trim this and make it a single line, only this part, and then we will continue with this line, so that in the next part, that is whenever we are moving this, it will be a separate entity. Okay, so now we will do the annotation. So this is the top face of the square prism, so let us annotate from here. So this is corner A, corner B, corner C, and corner D. And similarly, this is the bottom face of the square prism, which is corner A1, corner B1, followed by corner C1 and D1. And let us annotate the axis. So this is O and this is O1, which are the center points of the top and the bottom face respectively. So now he tells that the edge on which it is resting, that is A1, B1, is inclined to VP at an angle of 30 degrees. So now with that condition, we know that the edge is going to measure the same. So that is 35 mm here, and it is also 35 mm here. So the edge is not changing its dimension. So obviously it is not a beta angle problem. So now before we draw the the third position, that is the inclination with respect to the vertical plane, select the entire square prism and make this a rigid set. So the option for the rigid set is there in the relate menu. Select the rigid set and tell yes, and then this becomes a rigid set. So now we'll go for the select option, and then before selecting this, let us draw the 30-degree line. So I'll just offset this xy line to some distance, so that the edges whichever when placed at an angle of 30 degrees with respect to the VP is not going above the xy line. So for that purpose, let me draw a line offset at some particular distance to the VP, and then I'm going to draw a 30-degree line. So on this 30-degree line, I'm going to place the square prism. So now we will select this square prism along with the annotations and the axis line. So the square prism is selected. Select the move option, ensure the copy is on, and then keeping A1 as the reference point, place this point A1 on this 30-degree line. So you can just turn that, see that it is turning red. Okay, so now select the rotate option, keeping A1 as the first point of rotation, and next B1 as the second point of rotation. Let us just try to rotate this along the 30-degree line, and then let us just move this so that the edges are not going above the xy line. So ensure it is off and just drag it below to a convenient position. So you can see that this is the inclined position. So now let us use the trim option to trim this portion of the line. Let us show the inclination. So the inclination is 30 degrees. So the edges on which it is resting is inclined to the vertical plane at an angle of 30 degrees. So now let us complete the front view of the square prism in this condition. So let us draw the horizontal projectors first. So from the top face, let us draw the horizontal projections. And similarly, from the bottom face, let us draw the horizontal projections. So now let us draw the vertical projections. So let us select the first face, that is the bottom face. So from A1, so the point A1 is on the XY line. Similarly, from the point B1, it is on the XY line. Similarly, C1 is on the XY line. Sorry, it is on this locus of C and D, and here it is. And this is the locus of the axis, that is O1. So now you can just use the trim option and trim this portion of the line which is not required to us. And now let us just draw this front view. So let us select the line of thickness 0.50. So from A1 to B1, similarly from B1 to C1, C1 to D1, and D1 to A1. This is the bottom face of the square prism. So first we will construct the square prism and then do the analysis for drawing the hidden edges. So for that, we'll follow the step later. And now let us draw the projections for the top face of the square prism. So let us select the projection line of thickness 0.13. So from corner A, intersect the projection of A. From corner B, intersect the projection of corner B. From corner D, intersect the locus or the projection line from the corner D. Similarly, from corner C. Select the trim option, trim this line which is not required to us. And similarly, let us take a projection line from O and intersect the projection from O in the front view. So now this part is ready. So we shall draw the top face of the square prism. So select 0.50. So let us start from the corner A to corner B, then corner C, corner D, and corner A. And now let us connect the edges. So this is from C to, okay, this is from D to D. Similarly from A to A, A1, and this is from C to C1 and B to B1. So now we have got a set of rules here to follow. So what are those set of rules is no two thick lines shall intersect and no two thin or the hidden edges shall intersect. And also the edges will be hidden from the farthest corner point. So which is the farthest corner point from the observer here? It is obviously the corner C1. So from the point C1, all the edges will be hidden edges. So you can just see that if I select these three lines, it will fulfill all the conditions that we discussed. So you can just see that no two thick lines are intersecting, either this edge with this edge and this edge with this edge. They are not intersecting. So the thick lines are not intersecting at all. So the first criterion is fulfilled. And also the farthest corner point is C1, and from C1 all the edges are invisible. So now let us use the trim option. So now it is time for us to draw the axis line. So we'll select the line option of 0.13 mm thickness and let it be a chain line. So from O dash to O1 dash, this is the axis line. So now we will complete the annotation of the front view of the square prism with one of its edges inclined to the VP, and that edge being the initial edge on which it is resting. So let us do the annotation. So we know that it is resting on the edges A1 and B1. So let us annotate that edge first. So it is A1 dash and this is B1 dash, followed by the edge C1 dash, the corner C1 dash, and then the corner D1 dash. Similarly, this is B dash and this is A dash, followed by D dash and C dash. And then the axis points, that is O dash and O1 dash. So this is the axis line. So ensure all the annotations pertaining to the front view are always above the XY line, and ensure all the edges are annotated, all the corner points are annotated. So the thing is, you have to give the link between the corresponding edges, that is D dash to D1 dash, A1 dash to A dash, B1 dash to B dash, C dash to C1 dash, and also the axis from O dash to O1 dash. So with this, we complete the projection. So now let us just indicate the direction of the projection lines. So let us go for the leader option and select the arrow mark and change its color to black and indicate the direction of the projection lines. So with this, we complete the drafting for the given problem statement. So which states that there is a square prism of edges measuring 35 mm and having the axis length equal to 60 mm, which is resting on one of its edges on the HP, and its axis is inclined to the HP at an angle of 45 degrees, and then the edge on which it is resting is inclined to VP at an angle of 30 degrees. So with this, we complete the problem statement. Thank you all for watching.